Hi, Mr. Piercy here again. We're going to be investigating transformations of curves, but this time we're going to do something slightly different. We're going to transform it in a different way. So we're going to stick with f of x equals x squared, but this time we're going to either add or subtract a number inside the brackets instead of outside the brackets. So as you can see, I've added 2 inside the brackets, which has actually changed my input number. So instead of f of x giving me x squared, I've now got f of x plus 2, because x squared plus x plus 2 all squared. So I've transformed my function again, but just in a slightly different way. So let's have a look to see what happens in GeoGebra graphically when I transform this function. So if I change the value of k, instantly you notice that the curve is moving across the coordinate grid. So if I make this plus 1, what's actually happened is the curve has moved 1 unit to the left. If I make it plus 4, the curve's moved 4 units, to the left again. If I make it minus 3, it's moved 3 units to the right. Okay? And quite strangely, you may think that when I plus 1, the curve goes left, and when I minus 1, the curve goes right, which might seem a bit counterintuitive. So I'm just going to now explain why that's the case. So I'm going to go back onto Paint. Right, if you think about this, when we move this to, when we added 2 to this function here, the curve moved 2 left, okay, and we could see that the curve actually was touching the x-axis at minus 2. Okay? So on the x-axis, that's when f of x plus 2 is 0. So we can write this as 0 equals x plus 2 squared. And I can rewrite that as x plus 2 times x plus 2. Okay. Well, this equation here is only true if either this is 0, or this is 0, or both are 0. So, because they're both the same, that tells us that x plus 2 is 0, which means that if I take away 2 from both sides, that x is equal to minus 2. That's showing me that I have a root or I have 2 roots, but they're identical, called repeated roots, at x equals minus 2, which shows why the curve was touching the graph at x equals minus 2 when I plus 2 inside the function. So hopefully that gives you a good explanation as to why it moved left and it didn't move right. Let me just get rid of this. Now what we need to do is we need to describe this transformation. And again, this was a movement, but it was a movement across this time instead of up or down. So we still describe it as a translation, and we still use a vector to describe the translation. Of course, if you remember, this top number here describes the movement left or right. And when we add 2 inside the brackets, what actually happens is the curve moves 2 left. And the way we describe that is by writing minus 2, because left means negative here. If you remember what happened as well, the curve didn't move any units up or down. And this component here is the one that describes a movement up or down. So because it didn't move anything up or down, we have a 0 here. Okay? So this is kind of slightly, it seems counterintuitive, but obviously it's not. When we plus 2 inside the brackets, we've actually got a translation of minus 2 across. Let's try another one. Let's try f of x minus 1 squared equals x minus 1 squared. Well, again, this is a translation, because it's a movement. Okay? And we can use a vector to describe it. When we minus 1 inside the brackets, what actually happens is the curve goes 1 unit to the right, which we describe as a plus 1 there. And again, this is going to be 0 because there's no movement up or down. So hopefully those 2 examples and the GeoGebra examples explain to you how to describe these transformations when we add or subtract a number inside the brackets. Thanks a lot. Bye.